Welcome to the I am learning chemistry course on the topic of atomic and molecular structure. So today I am going to discuss in this video about shape of the atomic orbitals. So what I am going to discuss? At first I will try to discuss about shape of s orbitals, then shape of p orbitals, and finally the shape of d orbitals. Also, I will discuss about the radial probability distribution of all these s, p, and d orbitals. So let us start. So what is an s orbital? Basically, s orbitals are a spherical shape region where the probability of finding the electron is maximum. Now, s orbitals looks like this spherical, and when s orbitals actually appears when L equals to 0. That means when the azimuthal quantum number L has 0 value, then if we actually plot the electron probability, it's a basically mathematical plot, it will actually look like a spherical shape. So that's why it's an s orbital. So s orbital always appears when L equals to 0, and if L equals to 0, definitely the corresponding ml value will also have 0 in, and so ml has only one value, so that's why s has only one orbital. That you need to remember, and s orbital can take maximum 2 electrons. So now if we look at about the s orbitals, so it is nothing but the probability of finding the electron around that region is close to 90%. So what is an orbital? Generally all the atomic orbital, they are nothing but a geometrical shape which is derived from the mathematics by mathematical plot, and we describe this as an orbital because the probability of finding the electron is maximum in this region. And now if we plot the radial probability for one s orbital, now what is the physical meaning of this radial probability? It is nothing but if we move from nucleus towards the we can say that if we move from the nucleus towards the distance r, then if we try to figure out that where the probability of finding the electron is maximum, then we will get a plot like this. For example, in this case the maximum probability the finding of electron is at 52.9 picometer. So total radial probability versus distance, if we plot it for 1s orbital, you will get plot like this. So this is the radial distribution, radial probability distribution for 1s orbital. Basically, what is the meaning of radial probability distribution? It represents the total probability of finding the electron. That means if we move from nucleus, where we will get the electron, or where the chances of getting electron is maximum, the probability of finding the electron is maximum. That actually tells you, that actually told by this radial probability function. And definitely for every orbital there is a maximum distance from the nucleus where the probability of finding the electron is maximum, and there is a also region where the probability of finding electron is 0. For example, definitely for 1s orbital this kind of region is not there where the probability of finding electron is 0, but we will see for other orbital there will be some region where there will not be any electron found, and we will call that region as a node. We will discuss very soon. So if we plot the radial probability for 2s and 3s orbital, then we will see that there is a region where the probability of finding electron is 0, and that region is generally called node. For example, let's say this region there will not be any electron which is found for 2s orbital. For 3s orbital there are this kind of two regions where the probability of finding the electron is 0. Now what is these regions called? These regions are called nodes, and the number of nodes can be easily found by a very simplified formula. Number of nodes equals to principal quantum number minus azimuthal quantum number minus 1. So if principal quantum number is n, azimuthal quantum number is L, then your number of nodes will be n minus l minus 1. For example, for 2s orbital, n equals to 2, l equals to 0, so your node will be 2 minus 0 minus 1, that is 1 for 2s orbital. Similarly, for 3s orbital, your node will be 3, l equals to 0 minus 1 equals to 2. There will be 2 nodes for 3s orbital. As you can see from the figure, there are 2 nodes on 3s orbital, there are 1 node on 2s orbital. So if we plot the radial probability distribution, then there will be 2 regions in 3s orbital where the probability of finding of electron is 0, and there will be 1 region in 2s orbital where the probability of finding the electron is 0. Right. So in this way we can actually understand that in which particular portion the electron probability will be 0. So this is the probability, radial probability versus distance, radial probability distribution plot for 2s and 3s orbital. These are the node. These are the node which has been given by the dotted line. So now what we will try to understand? We will try to understand about the p orbitals. Now p orbitals is only possible if L equals to 1. That means p orbital must have n equals to 2 or greater. If n equals to 1, then there is no existence of p orbital, because L value is always 0 to n minus 1. So if n equals to 2 or greater, then only p orbital will come into the picture, because L must have the value of 1. So if L is 1, then definitely there will be 3 ml values, minus 1, 0, plus 1. So there are 3 p orbitals. And 3 p orbital means each orbital can take 2 electrons, so 3 p orbitals can take 6 electrons. And p orbitals are not same as like s orbital, they have completely different shape, and their shape is dumbbell shaped. Generally we have 3 p orbitals, and based on their orientation in space, they have been given name px, py and pz. So altogether there are 3 p orbitals, each orbital can take 2 electrons, so total 6 electrons. Similarly, we can have 3p, 4p, 5p and higher p orbitals. All have similar shape, but definitely they have different nodes, because number of nodes will be more and more as soon as we have higher order p orbitals, because number of nodes equals to n minus l minus 1. For example, for 2p we have n equals to 2, and for p l equals to 1. So what will be the number of nodes? 2 minus 1 minus 1, so 0. There will not be any node. So for 2p, if we want to plot the radial probability distribution, then there will be only one maxima and there is no minimum, or we can say there is no portion where the probability of finding of electron is 0. So there is no node for 2p orbital, there is no node. Similarly, for 3p and higher p orbital, we will find the nodes, and definitely accordingly you need to plot it. We will show it for at least 3p orbitals. So now d orbitals, again for d orbitals, it is only possible here L equals to 2. So it will only happen if n equals to 3, then only L will be 0 and 1 and 2. So if n equals to 2, then only d orbital will come into the picture, and if L equals to 2, there will be 5 ml values, so there are 5 d orbitals. 5 d orbitals means each orbital can take 2 electrons, so altogether 10 electrons. So 10 electrons can be accommodated in d orbitals. And definitely we can also plot the radial probability distribution plot for d orbitals. For example, if you wanted to plot it for 3d orbitals, then definitely how it looks like for 3d orbitals: n equals to 3, l equals to 2, so the number of nodes will be 3 minus 2 minus 1 equals to 0. That's why there is only single maximum, and there is no portion where it touches 0, or there is no region where actually the probability of finding the electron is 0. So for d orbital, we need to understand that L equals to 2, and accordingly you need to calculate the number of nodes for higher order d orbital like 4d, 5d. So how the d orbital looks like? So d orbitals are generally have this kind of shape, where you can say that based on their orientation in space and which plane it is actually there, accordingly the name has been given. For example, that is dyz, 3dyz, dxz, dxy. So xy, yz, zx or xz, and dx square minus y square, dz square. These are the 5 d orbitals and these are the shapes of these 5D orbitals. Definitely, in 3 dimension, if you look at their 3 dimensional orientation, then only you will be able to understand this. The naming. The naming has been given in which plane it is the orbitals are exist. For example, this is a YZ plane. This is a ZX plane. This is X and Y plane. This is definitely it's a combination of various permutation and combination from X and Y plane. This is also similar to that permutation combination from X and Y plane. So this is the shape. These are the shapes of d orbitals. These are very important. These d orbitals actually play a practical role in determination of various properties in several inorganic complexes. The whole coordination complexes, inorganic organometallic complexes, they are highly dependent on these d orbital configuration, d orbital orientations, and their magnetic properties, optical properties, magneto-electronic properties. All the things can be explained based on this concept. That's why these are very important and have real applications. Now, if you wanted to know about the how these d orbitals actually have in the t dimension, they are generally rotated like this, and this is we can say that a moving picture of d orbitals, how they actually appears in the 3 dimensions, right? So now I will show a few important radial distribution plot for few important we can say that orbital. For example, let's say why I have shown this 1s, 2s and 3s in one diagram, because so that you can understand how it looks. As soon as you go from we can say that from nucleus to more distance, then definitely the you can say that the maxima this height has been decreased, because the probability of finding the electron, definitely the number of electron, that will be less and less. And also you can see that in 1s there is no node, but in 2s there is one node, in 3s there are two nodes. So as soon as you go from 1s, 2s, 3s, the number of nodes also increases. So this is how the radial distribution plots look like for 1s, 2s and 3s orbitals. Similarly, if we try to plot radial distribution plot for 3p orbital, as I told, I will also show about 3p orbital. Then how many nodes will be there for 3p? N equals to 3 and L equals to 1. So definitely it will have 3 minus 1 minus 1, so 1. So 1 nodes, as you can see, this one, this is the nodes for sorry, this is the node for 3p orbital, right? One node only. For 3s there are two nodes, this one and this one already we have discussed. And for 3d there is no node, there is only single maximum, because for 3d we have already shown that n equals to 3 and l equals to 2, it does not have any nodes. So with that I conclude it, and we will see in the next video. Thank you.